Hi everyone, welcome to this episode of Keipert Labs. In this video today we're going to be discussing the concept of plate boundaries within the theory of plate tectonics. Okay, so we've looked at this idea that that in the past that if we're thinking about the Earth, and then the outside kind of layer of the Earth, the crust of the Earth, is actually, if we kind of this is our globe of our Earth, that actually that the Earth itself is broken up into a range of different pieces or chunks that we call our tectonic plates. Okay? And that then if we look in our wonderful Keipert's rubbish crust section, so we look here and we've got these are our chunks of lithosphere on the top, the chunks of our tectonic plates on the top, that then they float on this layer underneath called the asthenosphere. Okay, so hopefully this is all feeling quite familiar to you, even if the terminology I know is still fairly new in your mind. But this idea that they float on top of this soft kind of movable layer of the upper mantle called the asthenosphere. And so, and we've looked at this idea that inside the Earth we have this core, okay, that's hot, and so and then we have this mantle in the middle, which is this fluid kind of rock. And so that what happens is that that as the rock heats up, that it rises, gets to the top, and starts to cool down and sinks back down again. And we can see that this kind of happens as it goes around. We call these convection currents. Okay, and then we looked at this idea that that this movement of these convection currents, this kind of driving kind of force inside, then pushes on the asthenosphere, or makes the asthenosphere move, and it kind of drags the plates sideways, or kind of that they're moving. Okay, and so what that means, though, by way of kind of introduction, is that this idea that when the tectonic plates meet one another, that we get what's called a boundary. Okay, and so if we have tectonic plate 1, tectonic plate 2, okay, and that this spot where they meet is known as a plate boundary. Okay, and so depending on exactly what these plates are doing and which direction they're moving in, and what type of crust they are, we're going to see a range of different things that can occur at this boundary. Okay, so boundaries come in three main types: convergent, divergent, and then transform. And we're going to go through these in this video. Okay, so first of all, let's start with convergent. Okay, convergent is this idea of pushing together. Okay, so let's say that we've got tectonic, a tectonic plate like this. It's moving this way. Maybe we can say that this is, it's moving east. And then we have a tectonic plate over here that's moving west due to the movement in the asthenosphere underneath. So what's going to happen is that, while these plates are very slow in their motion, it might only be a couple of centimeters a year, perhaps, or maybe even slower, is that eventually, as they push together, eventually they get to a point at which they collide. Okay, so that these plates are actually kind of touching, or they're meeting one another at this boundary. And then what happens is that these plates continue to move towards one another, but the rock here is already in contact. Okay, so it's like, if you imagine this to be like a really slow motion car crash. Okay, so it's like, okay, well, car moving this way, a car moving this way, they get to a point at which they touch, but they're continuing to move. And so you can kind of picture that then the material, if I put that down and kind of see maybe if I do it under here. Okay, we've got the material as they're pushing together, then eventually that rock's got to go somewhere. So maybe they might push up together like this, or what typically happens is that one pushes up and the other kind of pushes down and slides underneath it. Okay, so what we see is kind of more like this. So plate 1 over here. Apologies for the neighbour's dog that never shuts up. Okay. So if this plate's moving west and this plate's moving east, eventually you get to this point at which this one starts to push down, or kind of like starts to slide underneath. Okay? So it's continuing to go down this way, and then this one's getting pushed up. So what we're seeing here, what we would notice with the landscape, is that we would be forming mountains. Okay, so as this crust this piece of the crust kind of goes down underneath, that forces this one to go up, and it's continuing to go up as this continues to they continue to slide towards one another, and so those mountains grow bigger and bigger over time. Okay, and so this is how we get things like the Himalayas or the Andes Mountains in South America. Okay, that so for the Himalayas, so we have kind of the Indian plate. This is totally not exactly, you know, accurate kind of drawing here. So we've got India and we've got Asia, and they kind of push towards one another, and so you get these mountains that kind of form at the boundary there. That's a really bad drawing, but you get the idea. Okay, and then but what we see is that this point here, in this gap in the middle, is known as a subduction zone. Okay, but there's this kind of this gap, or this point at which they're meeting and they're grinding against one another. So grinding rock is what's happening in this point. Okay, and so what it ends up, we've got this real, you know, this grinding, so we've got heaps of friction, which means that we've got lots of heat as that they're kind of rubbing together. And what that ends up being is that we end up melting rock due to that heat and that friction. And it's as it's pushing further down, and it kind of joins the mantle in under here, which is hotter. And so what happens is that at this convergent boundary, that this top one gets pushed up higher and higher over time, and then the rock of this plate underneath is basically being recycled, or being melted kind of at the edges as it slides in. Okay? Yeah, so convergent, pushing together, or a colliding boundary. Alright, let's keep things moving. Okay, so then we've got divergent. And so we're spreading apart. Okay, now this is typically, this typically occurs with oceanic crust. So thinking about that, it tends to be what we call mid-ocean ridges. Okay, which is one reason that it took us a long time to actually notice that this was something that happened, because they're in places that are very difficult to notice, to spot. Okay, so it's like, okay, so if we've got this plate here and this plate here that are kind of together, and then this one's moving west and this one's moving east, and so then what happens is that over time that this gap between these plates starts to widen, you know, stretching or kind of sliding or spreading further and further apart as time goes on. Okay, but basically, unlike, you know, what we could kind of then imagine is all of a sudden like this kind of this hole in the Earth's crust, and you could drop right down, and then you could kind of, you know, jump into the mantle or something silly like that. Okay, I'm sure there'd be someone dumb enough to do it. But the reality is that as this gap widens, if we kind of imagine, and we kind of go back to here, remember that we've got lots of hot kind of fluid rock under here that's kind of flowing in all sorts of directions and just churning around and underneath here. As soon as we open up even the tiniest little gap, okay, let's see if I can get another color so you can visualize what's happening, is that some of this rock kind of comes out and deposits. Okay, and as we get a little bit further, then we get a little bit more. That crack kind of opens up and we deposit some more. And so that kind of seals the gap. As it cracks open a little bit wider, we get more and more over time. As you know, that where that crack forms, that new fluid rock from underneath, so new fluid rock from underneath flows through the gap. And so what that does is that we end up with these deposits, these new kind of like underwater ridges of rock that form at these plates where these gaps are happening. Now, like I said, it's typically in the oceanic crust, but in places like Iceland, which is a really fantastic example, you might remember from that documentary that we looked at, that you can actually see a portion of this on land. And so it's this kind of this wonderful kind of gap, or this kind of rift that has happened that you can actually kind of walk in, or that you can, at different points you can even swim in, where there's a little bit of water in there, and then it's like over time that gap is spreading further and further apart. Those continents are actually moving away from each other. Okay? But yes, so we get mid-ocean ridges. Another place that this happens is in Eastern Africa. We got what's called a rift valley. So it's kind of like where the continent itself, rather than under the ocean, where the continent is moving apart. And so because of the fact that the mantle is still a long way down, that you don't get new rock coming up to the same extent, because it's got to get a lot further through, but you kind of get these gaps in the land that's widening. So these valleys that form over a long period of time. Okay. Lastly, we're going to talk quickly about transform boundaries, what we might call sliding boundaries. Okay, so that is, let's say we're looking top down, and then we've got this plate over here, and this plate over here that are next to each other, and this one's moving north, and this one's moving south. Okay, so remember this is a top view, as opposed to a side view. Okay, and so what's happening is that these plates are, rather than moving towards each other or pulling away from each other, spreading away from each other, they're actually grinding past each other. So what we get at this point, we get a tremendous amount of friction, because you've got massive kind of surfaces of rock, along, very, very deep, that are kind of so they kind of grind past each other. They're in constant contact, and they continue to rub against each other. So what we end up getting is that we've got a tremendous energy build-up that happens as a result. Because you imagine that we've got a lot of friction because we don't have smooth surfaces that are sliding past each other. That we have things that are very rough, with a tremendous amount of rock, and so that they don't easily slide. It's not like ice skating, that they don't slide neatly, but actually that they tend to jerk, or kind of, that they'll kind of press against each other and then just kind of snap, or kind of release. And so what tends to happen is we get an instant energy release, which ends up causing an earthquake. Okay? And so these sorts of, now, this is not to say that earthquakes only happen at these sorts of boundaries, that they can happen at other places because of that idea of the friction and that kind of grinding, instant energy release as opposed to a slow kind of movement. Okay? But transform boundaries like this are notorious for them because there's so much in contact, that's so much that's moving past each other. So a classic example, as I've mentioned in the previous video, was the San Andreas Fault. Okay, so all the way along the coastline of California. Okay, so if we can kind of picture that California kind of looks like, in the US kind of looks like this. There's other US states over here, and so what we have is we've got the Pacific plate moving one way, and then the North American plate moving another way, and so basically where they touch is where the coastline is formed, and so where all the really populous cities are, and so that we get a tremendous number of earthquakes that happen in places like Los Angeles and San Francisco and other places along the coast of California because of these plates that slide past each other. Okay, so just to quickly recap, so we've talked about convergent and divergent and transform boundaries where tectonic plates meet, and we can see that because of the movement of the rock and the way that they're going, that we get different effects, and we can notice different things. Alright, thanks very much for watching. Bye for now.